nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.
Good day, everyone. How was your day? Today is another day for a new learning in mathematics. I hope that you will discover math with joy and fun. So let's begin.
Na 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 2, 3. Let's sing it, you and me. Na 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 na. Mathematics is fun and easy. Na 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 na. Just take it slowly. Solving, count, multiply, find the totality. Na 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 na. Oh, math is what we need daily. Oh, math for life, we learn happily. Na 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 na.
Hello, learners. I am Teacher Pearl, and I'm welcoming you to the world of mathematics.
Proving statements on triangle congruence.
The learner proves statements on triangle congruence, M8GE-3H-1. At the end of the lesson, you are expected to apply triangle congruence postulates or theorems to prove that the two triangles are congruent. Prove that angles or sides of two triangles are congruent by using CP/CTC. And appreciate the importance of triangle congruence in real-life situation.
Mathematics, I know.
Let us arrange the following letters to give the acronym that stands for corresponding parts of congruent triangles are congruent. I'll give you a few seconds to do this. Time is up! Yes, the answer is CP/CTC. CP/CTC. Corresponding parts of congruent triangles are congruent. But what does this mean? It means that once that the two triangles have proven congruent, therefore all their corresponding parts are also congruent.
Mathematlink.
Before we proceed to our new lesson, let us have a short review about previous topic. Let us recall how angle LOB becomes congruent to angle CAT. Using the red tick marks on both triangles, can you complete this statement below? If triangle LOB is congruent to triangle CAT, then segment LO is congruent to blank. If your answer is segment CA, then you are correct. Let's try another. If triangle LOB is congruent to triangle CAT, then angle O is congruent to blank. If your answer is angle A, then we have the same answer. Now, without figures given, can you also complete this statement below? Given only congruent triangles, can you find the congruent angle congruent to angle D? If your answer is angle C, then you got it right. What about this? Find the congruent part of triangle CAT for segment DG. Did you get the same answer? Congratulations! Now, by observing the number of tick marks on both triangles, can you determine the triangle congruent to triangle DOG? Time is up! Yes, the answer is triangle SIT. And for our last question in our review, can you complete this statement too? Triangle OGD is congruent to blank. So if you will get it correctly, I guess you enjoyed this activity.
Take note of this. In a congruent statement, order is the key. Everything in this statement talks about pairing and matching.
Triangle LOV is congruent to triangle CAT. It's because L corresponds to C, O corresponds to A, and V corresponds to T.
So we can say that the two triangles are congruent if the three corresponding sides have the same length and the three corresponding angles have the same measurement.
Mathematics new.
For our activity 1, determine the property or definition that is used in the following statements. In a parallelogram ABCD, segment BD is congruent to segment BD. What property can you reason out?
Reflexive property of congruency.
That's fantastic.
In triangle ABC and triangle DEC, angle BCA is congruent to angle ECD. What property or definition can you reason out?
Vertical angles theorem.
Very good.
Segment BA is parallel to segment DC. Angle ABD is congruent to angle CDB. What property or definition can you reason out?
Alternate interior angles are congruent.
Bravo.
Recall the postulate or theorem of the given statements. You may draw triangles to illustrate the statements. If segment MA is congruent to segment FU, segment AT is congruent to segment UN, and segment MT is congruent to segment FN, then triangle MAT is congruent to triangle FUN. So the answer is side, 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 or SSS congruence postulate, because we have 3 pairs of congruent sides. Number 2. If segment RI is congruent to segment AY, included angles I and Y are also congruent, and segment FI is congruent to segment DY, then triangle FRI is congruent to triangle DAY. Side angle side, or SAS congruence postulate, because we have 2 pairs of congruent sides and 1 pair of congruent included angles. Number 3. Triangle FIL and triangle ENG are right triangles at angle I and angle N respectively. If segment FI is congruent to segment EN and segment FL is congruent to segment EG, then triangle FIL is congruent to triangle ENG. The answer is hypotenuse leg, or HYL congruence theorem. Number 4. If angle M is congruent to angle T, angle MAH is congruent to angle TAH, and non-included sides are congruent by reflexive property, then triangle MAH is congruent to triangle TAH. The answer is angle-angle side, or AAS congruence theorem, because we have 2 pairs of congruent angles and 1 pair of congruent non-included sides. Number 5. If angle ANY is congruent to angle MOR, angle AYN is congruent to angle MRO, and segment NY is congruent to segment OR, then triangle ANY is congruent to triangle MOR. So the answer is angle side angle, or ASA congruence postulate, because we have 2 pairs of congruent angles and 1 pair of congruent included sides.
Mathematic talk.
Let us find out how we can apply the congruence postulates and other definitions to prove that the 2 triangles are congruent. Study the following examples. Example number 1. Given, segment FL is parallel to segment SA. Y is the midpoint of segment LA. Prove that segment FL is congruent to segment SA. Okay, let us have the 2-column form. Statement number 1. Segment FL is congruent to segment SA. Y is the midpoint of segment LA. Reason given. Statement number 2. Angle 1 is congruent to angle 3. Reason: alternate interior angles are congruent. Number 3. Segment LY is congruent to segment AY. Reason: definition of a midpoint. Let us recall the definition of a midpoint.
If points P, Q, and R are collinear, and Q is the midpoint of segment PR, then segment PQ is congruent to segment QR.
Number 4. Angle 2 is congruent to angle 4. By the definition of vertical angles theorem, If you had noticed, we have two pairs of congruent angles and one pair of congruent sides. Number 5. Triangle FLY is congruent to triangle SAY, where each side is common between two angles. We can say that the two triangles are congruent by ASA congruence postulate. Therefore, we can now conclude that segment FL is congruent to segment SA by CPCTC, or corresponding parts of congruent triangles are congruent. Example number 2. Segment IE is a diagonal of a parallelogram LITE. Prove that segment LE is congruent to segment TI. But what is a parallelogram? According to my friend,
Parallelogram is a quadrilateral with two pairs of parallel sides.
Statement number 1. Segment IE is a diagonal of the parallelogram LITE. Reason? Given. Number 2. Angle LIE is congruent to angle TEI. Alternate interior angles are congruent. Number 3. Angle LEI is congruent to angle TIE. Alternate interior angles are congruent. Number 4. Segment IE is congruent to segment EI. Reflexive property of congruency. Number 5. Triangle LIE is congruent to triangle TEI by ASA congruence postulate. Therefore, we can prove that segment LE is congruent to segment TI by CPCTC. Example number 3. Given segment SH is congruent to segment IH. Angle SHP is congruent to angle IHP. Prove that P is the midpoint of segment SI. Statement number 1. Segment SH is congruent to segment IH. Angle SHP is congruent to angle IHP. Reason? Given. Segment HP is congruent to segment HP by reflexive property of congruency. Now that we have two pairs of congruent sides and one pair of congruent included angles, we can say that triangle SHP is congruent to triangle IHP by SAS congruence postulate. And by that, segment SP is congruent to segment IP by CPCTC. Therefore, P is the midpoint of segment SI by the definition of a midpoint.
Matcha, try this.
For practice exercises, fill in the blank to complete the table. Choose the correct answer from the boxes given below. Given, R is the midpoint of segment SU. Segment ST is congruent to segment UT. Prove that angle S is congruent to angle U. Statement number 1. R is the midpoint of segment SU. Which do you think is the reason? Choose your answer from the given boxes below. Time is up! So the answer is given. And from that given, what statement will you write next to have a reason of definition of a midpoint? And the answer is segment SR congruent to segment UR. Statement number 3. Segment ST is congruent to segment UT. What do you think is the answer? Since it is written in the given, so the reason is given. Now let us have side TR congruent to side TR. What do you think would be the appropriate property for this? The answer is reflexive property. Triangle STR is congruent to triangle UTR by SSS congruence postulate. So for the last one, angle S is congruent to angle U. And Since the remaining answer is CPCTC, so the answer is CPCTC.
Practice exercise number 2.
Angle O is the midpoint of segment TG. Angle T is congruent to angle G. Prove that angle H is congruent to angle D. Statement number 1. O is the midpoint of segment TG. What do you think is the reason? Reason given. And from that statement, statement number 2, side OT is congruent to side OG. Definition of a midpoint. Additional given. Angle T is congruent to angle G. Check your answer. Next, angle HOT is congruent to angle DOG. Reason, vertical angles theorem. So we can say that triangle HOT is congruent to triangle DOG by ASA congruence postulate. Therefore, angle H is congruent to angle D by CPCTC, or corresponding parts of congruent triangles are congruent.
Practice exercise number 3.
Given, angle A is congruent to angle D. Angle 3 is congruent to angle 4. Prove that side AB is congruent to side DC. Statement number 1. Angle A is congruent to angle D, and angle 3 is congruent to angle 4. Reason given. Since that the two base angles are congruent, we can say that triangle BCE is an isosceles triangle. Reason, converse of isosceles triangle theorem. Statement number 3. Segment BE is congruent to segment CE. From the definition of isosceles triangle. Another corresponding parts that we can already mark congruent are angle 2 and angle 6. What reason can you give? Correct! The answer is vertical angles theorem. Now it's time for you to give the theorem or postulate why the two triangles are congruent. Now that we have two pairs of congruent angles and one pair of non-included sides, so we can say that triangle BAE is congruent to triangle CDE by AAS congruence theorem. And from that reason, we can say that side AB is congruent to side DC by CPCTC. Did you find our topic interesting? Come on, let's try to summarize what you have learned today from our discussion. CPCTC. Corresponding parts of congruent triangles are congruent. There are only 5 methods to prove triangles congruent. Here are they. The first one is the side-side-side or SSS congruence postulate. All sides of one triangle are congruent to the 3 sides of another triangle. The second one is the side-angle-side or SAS congruence postulate. The 2 sides and an included angle of one triangle are congruent to the 2 sides and an included angle of another triangle. The third one is the side-angle-side or ASA congruence postulate. The two angles and an included side of one triangle are congruent to the two angles and an included side of another triangle. The fourth one is the AAS or angle-angle side congruence theorem. The two angles and a non-included side of one triangle are congruent to the two angles and a non-included side of another triangle. The last one, but not the least, is the hypotenuse leg or HYL congruence theorem. The hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle. Another things to remember, the pair of corresponding angles or sides are congruent if they satisfy the following using markings: reflexive property of congruency, vertical angles theorem, alternate interior angles are congruent. Mang Tani was alarmed by the incoming super typhoon or rain. That is why he needs to repair his roof using two equal triangular pieces of material. He named the two with triangle MIT and triangle LOF. Can you help Mang Tani to answer the problems below? If triangle MIT is congruent to triangle LOF, complete its congruent statement below.
Okay, so I hope that you learned a lot of things in our lesson today. See you next time. Be safe and well.
Na 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 na. 2, 3. Let's sing it, you and me. Na 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 na. Mathematics is fun and easy. Na 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 na. Just take it slowly. Solving, count, multiply, find the totality. Na 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 na. Oh, math is what we need daily. Oh, math for life we learn happily. Na 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 na.
Hello, grade 8 students. I hope you are all safe and well. I am Sir Richard. Now you've reached the last part of your Quarter 3 Mathematics 8 lessons, which involves application of triangle congruence to construct perpendicular lines and angle bisectors. Before we proceed with the discussion, let me check if you can still remember the 3 basic triangle postulates, the steps on proving that two triangles are congruent, and solving corresponding parts of congruent triangles. Worry no more! Let's take a quick recap of the SSS, SAS, and ASA congruence postulates, proof for two congruent triangles, and solutions in finding the corresponding parts of congruent triangles. First, you may notice the markings on side MP corresponds to side RS, angle P corresponds to angle S, and side NP corresponds to side QS. Therefore, triangle MPN is congruent to triangle RSQ by SAS postulate or side angle side postulate. Next, the markings shown on each side of triangle ABC has the corresponding congruent side on triangle DEF. Sides AB, AC, and BC are congruent to sides DE, DF, and EF respectively. Therefore, triangle ABC is congruent to triangle DEF by side postulate. Lastly, in between two angles is an included side, emphasized by the markings on each triangle. It also shows that angle B is congruent to angle E, side BC is congruent to side EF, and angle C is congruent to angle F. Therefore, triangle ABC is congruent to triangle DEF by ASA postulate or the angle side angle postulate. How about solving corresponding parts of congruent triangles? Let's use this example in which we were given triangle PQR is congruent to triangle LJK. Also, angle P is equal to 5x minus 15 degrees. Angle L is equal to 4x plus 5 degrees, and angle Q measures 2x minus 5 degrees. What is the value of x and the measure of angle J? Here's the solution. Since angle P is congruent to angle L, which were our given measures, we can create an equation to solve for x, such that 5x minus 15 is equal to 4x plus 5, as the measure of angle P and the angle L respectively. By addition and subtraction property of equality, we can rewrite the equation as 5x minus 4x is equal to 5 plus 15. And by simplification, we can now show the value of x is equal to 20. After getting the value of x, we may now solve for the measure of angle J. But we notice that there is no given algebraic expression for angle J. So what we can do is to find the corresponding angle, which is angle Q, and use its algebraic expression 2x minus 5 since they are congruent. Let us substitute 20, which is the solved value of x, and simplify. As a result, we get 35 for angle Q, which is also the measure of angle J. Please pause and replay the solution whenever you need to recall the process. There you go! We are now ready to apply the basic principles of triangle congruence to our new topic. So, heads up! Make your paper, pen, pencil, ruler, and compass ready to apply triangle congruence in constructing perpendicular lines and angle bisector. An angle bisector is a line, a ray, or a segment that divides or cuts an angle into two equal or congruent parts. Let's say, for example, we have ray BX as an angle bisector of angle ABC. Ray BX is an angle bisector of angle ABC if and only if point X is inside or in the interior of that angle, and the two angles formed, namely angle ABX and angle CBX. That is how an angle bisector is illustrated. Normally, we can use a protractor to measure an angle and divide it into two congruent parts. But how are we going to construct an angle bisector using a ruler and a compass? The most important part of this procedure is by locating the interior point that will be connected to vertex E. First, place the pointed end of the compass to vertex E and freely draw an arc intersecting the rays of angle, as shown in red. Next, Place the pointed edge of the compass to the intersection and draw the second arc inside the angle, shown in blue. Third, without changing the opening of your compass, repeat the previous step on the other ray of the angle by creating intersecting arcs inside the angle, shown in yellow. Lastly, connect the vertex and the point of intersection, which can be labeled as point O, of the arcs to form a ray. And that is our angle bisector. But we are not yet done. Let us prove that the ray formed is the angle bisector. Let's clean the unnecessary lines and rename the points. Connect lines on a point on each ray from the endpoint V of the segment, creating 90 degrees on angle O and angle E. Let us prove that segment LV is the angle bisector of angle OLE in quadrilateral LOVE. First statement shows that segment LO and LE are congruent, as well as segment VE is congruent to segment VO by construction. Segment LV is congruent to segment LV by reflexive property. Therefore, we can conclude that triangle LOV is congruent to triangle LEV by SSS, or side-side-side postulate. It follows that angle OLV is congruent to angle ELV by CPCTC, or corresponding parts of congruent triangles are congruent. Lastly, we can now prove that segment LV bisects angle OLE by the definition of angle bisector, which tells us that an angle bisector is a line, ray, or segment that divides an angle into two congruent parts. Then we can now state the theorem of angle bisector that if a point is on the bisector of an angle, then the point is equidistant from the sides or rays of the angle, and from the previous figure shows 90 degrees on both angles. How about solving for an unknown value using an angle bisector? Let's try solving the given example that shows ray AT is an angle bisector of angle MAH, in which the measure of angle MAT is equal to 7x minus 12 degrees, and the measure of angle HAT is 4x plus 6 degrees. And let's solve for x. Using ray AT as the angle bisector of angle MAH, it forms two congruent angles that will create an equation 7x minus 12 is equal to 4x plus 6 from the measures of the respective angles. By addition and subtraction property of equality, we can rewrite it to 7x minus 4x is equal to 6 plus 12, and leaving 3x is equal to 18 when simplified. And by division of 3 on both sides of the equation, we can get x is equal to 6. Don't forget to press the pause button and replay the solution if needed. Now let's proceed to the second part of our lesson. After the angle bisector, we have perpendicular lines, which are lines that intersect at a right angle. Suppose we have line X. Identify the perpendicular lines. We have A, B, and C. Again, identify the line or lines perpendicular to line X. If you answered B and C, then you're right. A line can be a bisector and perpendicular to a line or segment at the same time. We can call it as a perpendicular bisector. A perpendicular bisector basically creates a 90-degree angle and is located at the midpoint of a segment, cutting that segment into two congruent parts. By analysis, it also shows that a perpendicular bisector is the set of all points equidistant from the endpoints of a segment. To explain further, let us use segment PR with midpoint M that creates two congruent segments shown by the markings. Following a line passes through point M and creates a 90-degree angle. Let's say, for example, we have point A from the perpendicular bisector. The distance from point A to point P is equal to the distance from point A to point R, or the distance from point B to point P is equidistant from the distance from point B to point R. Same rule applies to the distance from point C to point P and from point C to point R. It simply shows that the distance from the endpoints of a segment are symmetrically equidistant to any points of the perpendicular bisector. Basically, we can create a perpendicular bisector by measuring 90 degrees using a protractor. But you can easily construct a perpendicular bisector using your plane ruler and compass, similar to the first part of this video lesson. First, label the endpoints of a segment. This time we are using H and F. Second step, place the tip of your compass on one end of the segment and draw an arc occupying more than half of the segment, shown in red. Third step, repeat the previous step on the other end of the segment without changing the opening of your compass as shown in blue. Fourth step, you will notice that there is a point of intersection of the two arcs. Draw a line joining them and label it as segment AL, while the midpoint can be named as point X. You should create two pairs of congruent segments and 90 degrees on the corners. Let us remove the unnecessary lines and leave a triangle for us to prove that segment AX is the perpendicular bisector of segment HF. First, segment HF is congruent to segment FX, and the measure of angle AXH and angle AXF are both 90 degrees as shown in our construction using ruler and compass. Second, segment AX is congruent to segment AX by reflexive property. Third, we can now conclude that triangle AXH is congruent to triangle AXF because we have proven a pair of congruent sides, a pair of congruent angles, and another pair of congruent sides that can be interpreted as SAS postulate or the leg theorem in congruent right triangles. Fourth, segment AH is congruent to segment AF by CP/CPC, which are also the hypotenuses of the two triangles. Lastly, segment AX can be proven as the perpendicular bisector of segment HF by definition of perpendicular bisector, which involves a point equidistant from the endpoints of a segment. Using the figure, we can say that segment AX is the perpendicular bisector of segment HF because the distance from point A to point H is equal to the distance from point A to point F. It follows that if a point is on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment as our perpendicular bisector theorem. How about solving the value of x given that in triangle LDS, segment OS is the perpendicular bisector of segment LD, and LS is equal to 8x and DS is equal to 5x plus 12. Since it is proven that LS is congruent to DS, then we can create an equation 8x is equal to 5x plus 12. By subtraction property of equality, we can simplify the equation to 3x equals 12 and divide 3x by 3 and 12 by 3. We can get the value of x is equal to 4. Do you find the part confusing or difficult to understand? You can pause the video and go back on the previous part of the discussion. Now, for our third and last part, ask yourself, do I fully understand the lesson? If your answer is a big yes, then challenge your skills with this quick quiz. For quiz number 1, in quadrilateral EOMC, segment EM is the angle bisector of angle CEO and angle CMO. Letter A. Answer the following as true or false by writing a check or X mark on your paper. Number 1. Angle CEL is congruent to angle LEO. Number 2. Angle CEM is congruent to angle MEO. Number 3. Half the measure of angle CEL is equal to the measure of angle LEO. Number 4. Angle CML is congruent to angle CMO. Number 5. Angle CLE, angle ELO, angle CLM, and angle MLO measures 90 degrees. Letter B. Find the value of x. Letter C. Solve for the measure of angle CMO. Pause this video and use a piece of paper, a pen, or a pencil to answer the following questions. Take your time and good luck. Okay, check your answers. Did you get a perfect score? Great! We're not yet done. Challenge yourself with quiz number 2. Ready? Go! In quadrilateral EOMC, segment EM is the perpendicular bisector of segment CO. Letter A. Identify the segments congruent to segment EM, segment LM, segment CE, and segment LO. Letter B. Find the value of y. Letter C. Solve for the length of segment CM. And letter D. If CO is equal to 20 units, solve for CL. Again, pause this video so you can write your solutions and answers on your paper. Give your best shot. Do you want to know if you got it right? Here are the correct answers. Did you miss some of the questions? It's alright. You may still replay this video and keep track on the things that you have missed. Did you get all answers right? Wow, great job! Congratulations! Now you're ready to answer your modules. Do you have questions, ideas, suggestions, or clarifications in mind? Please do not hesitate to contact your Mathematics 8 teacher. Goodbye! Thank you for watching this video. Share this to your classmates and friends so they can also learn the topic. Stay safe by washing your hands, wearing face mask and face shield, and by observing physical distancing. Goodbye!
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.